This is part 2 of my Space Invaders playlist for videos. Today we'll be talking about the important code and details that went behind actually making the game what it was. Let's get started. Let's start with our class diagrams. As you can see, we had 4 main panels. I don't know if you get the joke because there's a main panel, but anyway. The three important panels when it came to switching scenes and giving player information. The main panel, which is the main menu panel, the game over panel, which happens when the game is over, and the mods panel. All 3 of these panels had instances of the animated panel, so where they could use things like get rand color and get limited color to make their buttons different color for their paint component. Both the main panel and the mods panel implement an action listener, implement the interface action listener, because for their buttons, when they're clicked, a specific event is supposed to happen, and we need to know when that happens and and what event to do. An action listener is the thing to do. Next, let's go into our game class diagram. We can see here that the game panel is king. The game panel has instances of enemy bullets, special enemy, skin, obstacles, players, enemies, enemy bullets, player bullets, you name it. It rules this kingdom. This rect object over here represents the hitbox. So all collidable objects will need to have a rectangle instance, like an enemy bullet, a player bullet, enemies, special enemies, the player, the obstacles, which is like the things that the player hides behind. These were the 2 main things that I wanted to focus on when making my class diagrams, to show that, okay, the game panel is where everything happens, and all collidable objects will have a hitbox rectangle as shown over here. There are other small connections, like the player will have player bullets, the special enemy, and the game panel has a special enemy, and the game panel has a skin, and so on. But the 2 main ideas is that the game panel rules the game class diagram, and all collidable objects will have a hitbox rectangle. Let's talk about important functionality, starting with the player. The player is represented as a sprite in this spaceship here. This is done by using these 2 methods. Once again, credit to Stack Overflow. The buffered image resize will turn a normal image into a buffered image and reset that temporary image around 0, 0, making sure that we get the entire image and we create the 2D graphics for it. This resizable image will then go into the draw image function, in which case where we take in our graphics object, the file name for the image, and the size that we want, and the locations. From there, it'll create a buffered image, and then it'll draw that image using our graphics object that we're given. There's other things like when you press the A and D keys, the player moves, but that's through keyboard input. And the spacebar to 5, that's simple. We use a key listener for doing that. Next, let's talk about our enemies. Our enemies' movement follows a specific algorithm, as shown in this snippet of code over here. We go through every enemy, and if the enemy is angry, or their size is less than 5, we increase their speed, and we make sure that they fire more often. This is like the Berserk mode that I showed in the previous episode. Make sure to check it out if you didn't catch it. If there is a speed boost, then we increase their speed. But then we come into here. If the X position is greater than 1450, meaning that they hit the bounds over here, then we say the enemy moves left. If we come into our move left position, that means the enemies move down, they move to the left, and then they go to the right minus the speed. And then if the enemies hit the left bounds, then they go down and then they move to the right. And then the normal move is that they just move in the same direction as before they hit the boundaries, which is set using a Boolean. This is the algorithm for the enemies. The special enemy is kind of like a watered down version of this. It'll move until it hits a boundary, then it'll bounce back. It's kind of like the normal enemies, only without the moving down. He just stays at the top. He just roams around there. The most important thing for my game was collision detection, because obviously you can't have a shooter, well, you'd have a really bad shooter if there was no good collision detection and there was no checking whether the objects collided. This is the code for the hitboxes for the rectangles. They all used axis-aligned bounding boxes, and then this is the function for checking whether 2 objects have collided, or whether the 2 rectangles have overlapped. So the way I did it was that for all collidable objects, I had a hitbox rectangle around them, and then every frame in the animation method, I checked to make sure that, okay, have like the end player bullets and then enemies overlapped. If this is true, then a specific event should happen. When that's been, and I use this function to check whether the two rectangles have overlapped or collided. Finally, the score. The score is the accumulation on how well the player did in the game. It's increased on some significant two factors, whether the enemies have been destroyed or whether the special enemy has been destroyed. And then it decreases based on how many times the player gets hit and the number of times the obstacle gets hit. Now you might be wondering, but wait a second, how does the high score work? How do you keep track of every single game that you've played, even when the application is closed or the user quits and turns off the game? What I did was that at the end of every game, I used a buffer writer to write the score to a file, scores.txt. And then when I write the score, at the game over panel, I used a scanner to go through every single line in the file to find the highest score. This is how I displayed the high score, and then the normal score was just passed in from the game panel to the game over panel. This gave me a great amount of persistence of score and a persistence of high score, and thus why I was able to display both the score and the high score. That's all I have for today's video. Make sure to check out the third video, in which case I will be talking about fun extensions and expansions to make sure that the game isn't monotonous and boring, which, from prior experience, I can tell you, no one likes monotonous and boring games. Make sure to check it out, and I'll see you then.